Hello everyone, my name is Josias. I am a Master Science student at the University of Campinas. The title of my project is a comparing WAG-CO2 injection with continuous water and gas injection in separate wells for the development and management of a CO2-rich light oil fracture carbonate reservoir, subject to full gas recycling. So this work is ongoing and is being part of this project Susana, Antônio and Denis. So here I have just a little introduction with some motivations and the objective of this project. Driving by operational challenge, regulatory constraints on gas flaring, and government concerns with carbonate zero. Many projects in the Brazilian pre-sal assume the use of water alternating gas injection as a default recovery mechanism for this environmental, right? And because this method has some advantages such as improve oil recovery. However, studies that compare these advantages with a simple management plan are not common. The objective of this work is to compare WAG and continuous injection of water and gas in separate wells subject to full gas recycling. For this, we consider the Unicamp benchmark, a natural fracture carbonate reservoir with Brazilian pre-sal characteristics, especially the Unicamp 2 DCO. This is a coarse grid compositional simulation model, and I represent this model in this map here. We use the model-based decision analysis, especially the blue part of the 12-step methodology that represent the step 6 to 11, and in this case I will present only the step 6 and 7. The step 6 is the production strategy optimization for the base case. This is the representative model 1, and the step 7 represent the initial risk analysis. So here I have my general workflow of my project that have 5 activities. The activity 1 represents the specialized production strategy optimization, considering continuous injection and WAG for the representative model 1. The activity 2 represents the risk analysis, selection of representative models, and optimization of the specialized production strategy for other representative models, considering both recovery methods. 3 represent the cross-simulation strategy optimization for both recovery methods. 4 represent the comparison and selection of production strategy. And 5 application of selected strategy in the Unicamp 2R for validation. So for this special presentation, I will focus on the results of activity 1 and activity 2 for risk analysis, and activity 3 for the representative model 1. So to assess my best strategy during the optimization process, I consider the net press value as an objective function, the nominal optimization method, and some algorithms to maximize the objective function, such as ideal HC, MCC, and 2opt. The first is a global optimizer, and the others a local optimizer. So, and I consider this hierarchical optimization process to assess my specialized production strategy, right? So this hierarchical optimization process was divided between G1 and G12 decision variables. So I not discuss all of these subgroups, but the idea is to implement all of these steps in the process to select my specialized strategies. But for cross simulation, I consider just this G12 optimization, right? Why I consider just this? Because the idea of the cross simulation is to change my best G1 optimized for each recovery method in this step here, and apply a new G12 optimization for these strategies, right? So with this process, the idea is to assess the flexibility and the quality of the optimization process, right? So just remember, this is a process to assess my best strategy during the optimization process, but to select the final production strategy is, is important you consider the expected monetary value and the risk analysis with downside risk and upside potential, right? To incorporate the uncertainty in the process. So here I have the results of economic and production indicators. In solid colors I have my specialized strategies, and gradient colors I have my cross simulation strategies. So in blue I have the the continuous injection, and in black I have my WAG injection results, right? And in red I have the oil recovery factor. So looking for this graphic here, it's possible to see that I don't have some difference in terms of specialized strategies, right? For the net present value. And another point is that I have only 2% difference in terms of oil recovery factor between these two strategies. Another point is that cross simulation for continuous injection compared to specialized strategies for continuous injection decreased 14% in the NPV, while cross simulation for WAG compared to specialized strategies increased 4% in the NPV. So here I have the decision variables defined in J1. Here I have the well number, and here I have the platform size. And in blue I represent the specialized strategies for continuous injection, and in black the specialized strategies for WAG. So here I have the delta between them, and if I look for these results, it's possible you see that I have just a little difference here in terms of liquid production capacity, but in general it's possible to see that I don't have some difference in terms of these decision variables between these two recovery mechanisms. So in terms of well placement, I plot these graphics here that represent the oil production potential map. This is a final oil production potential map, right? And I plot together with this well placement. So looking for these two figures here, these two maps, it's possible to see here the J1 optimized for continuous injection, right? And in this case here, J1 optimized for WAG. Look for these two in this moment. So this J1 of continuous injection perform better switch for itself and for cross simulation for WAG, right? But the opposite was observed for J1 optimized for WAG. Why? Because it's possible to see here that I have oil yet in this region and this region too, right? So in special case of this cross simulation for continuous injection, this is the worst strategy due to the placement of injectors. Why? Because if you look here for blue, I have my water injectors, red my gas injectors, and green producers, right? So in this strategy I have water injectors in the peripheral region, right, of the reservoir, and in gas injectors in the middle of this reservoir, right? So this is achieve a low repressurization of this reservoir and a high gas production, which converts for a large number of closed producers in this strategy. So in terms of initial risk curve, I plot here in blue dashed line the cross simulation for continuous injection, in black dashed line the cross simulation for WAG injection, right? And continuous line I have in blue the specialized strategy for continuous injection, and in black the specialized strategy for WAG, right? So looking for this figure, it's possible to see that I don't have some difference between my specialized strategies, right? When I plot the risk curve for the sample. And another point is that the risk curve of cross simulation strategies shows the bias that we can achieve in the rows choose of the production strategy, right? Another point that I forgot to highlight here is this head dash line here. This represents my benchmark return, right, of the project. This is the loss and gain defined by the decision maker. And these dots here represent the representative model 1, the strategy that was optimized. So here I have my EMV versus risk for downside risk and upside potential, right? So to assess my best strategy, I need to represent in this area my best downside risk, and in this area my best upside potential, right? Looking for these two graphics here, it's possible to see that my best strategy is really the cross simulation for WAG. So in concluding remarks, both specialized production strategies could be selected as a recovery mechanism. Search did not present a significant difference in terms of decision variables, mainly platform size and economic and production indicators, right? Why? Because if you look for this table here, for example, that represent my objective function, I have just 0.03% difference between the specialized strategies, right? The best alternative was the cross simulation for WAG, which suggests a local maxima for specialized strategies for WAG and a great flexibility for future changes in the recovery method for WAG. Which is this local maxima? This is a point which is a maximum related to its neighbor value, but is not a global maximum. The worst alternative was the cross simulation for continuous injection, which suggests just an efficient optimization for specialized strategies for continuous injection and an inflexibility for future changes in the recovery method for continuous injection. So in the next steps, I highlight here in green the activities that I finish, and in red the activities that is ongoing, right? So for example, here I have ongoing the optimization of the specialized production strategy for other representative models. I need to apply the cross simulation for these other representative models, compare all of these results and select my final production strategy based on EMV and risk, and apply these strategies in the Unicamp 2R for validation and quantify the real value of the information. So this is the reference, and thank you for attention.